All right, continuing on with our exploration of exponents, let's do the next few rules here. So we talked about multiplication division in the previous video, and then rule number 3 is going to be parentheses. Probably not spelling that correctly, but whatever. And the way that we do this is we are going to multiply the exponents. So here's an example of this. Supposing I had, let's put it in purple. Supposing I had something inside a parenthesis, let's say I had x cubed. And then on the outside of the parenthesis I have another exponent, 4. What we do here, is this outside exponent is going to be multiplied by every exponent inside the parenthesis. Which in this case we only have one term, right? We just have the x in there, so it's just going to be that. So it'll be x to the power of 3 times 4, which is going to be x to the power of 12. Okay? So that is the parenthesis rule, just multiply. However, obviously, we can complicate it a little bit. Supposing I had a couple of different terms. Supposing I had x squared y cubed inside the parenthesis, and on the outside I had a 7 hanging out there. Well, same rule. We're going to take this outside parenthesis and we're going to multiply it by all the parentheses inside, which in this case, all the exponents inside, which in this case, it's 2 of them, right? Because we have a y term and an x term. So that's going to be x, let's do the x one first. So that's going to be 7 times 2, that's going to be to the 14th power. And then the y is going to be 7 times 3, that's going to be to the 21st power, which would be an alarmingly large number if y was, never mind, anyway, I'm babbling. Okay, so that's all you have to do there. Now, as a reminder, this is a very common trap on the SAT because you'll get something like this. This is where a lot of students stumble. So pay extra attention to this part. Supposing I had something like so. 2a squared b 3 to the 4th power. Okay? This is what students will typically do. Just because they're not familiar with this. But it'll say, oh, okay, that's going to be 2a to the 8th power, right? Because it'd be 4 times 2, b to the, 4 times 2, b to the 12th power. They say that's your answer. That is wrong. Okay? The mistake is that you forgot that you also have a 2 in there, along with the a and the b. Every single term has to have its exponent multiplied by 4. So even though it's not written down, hopefully this makes sense to you that the exponent for 2 is just 1, right? Because we just have 1, 2 in there, right? It's just 2, not times itself. It's just hanging out alone. So it's just 2 to the 1. So the correct answer is going to be 2 to the 1 times 4 is 4. A to the 8th. B to the 12th. Just don't forget to do that. If you have a regular number in there and not just the variables, you still have to raise that exponent, multiply that exponent by the outside exponent as well. So this would be 2 to the 4th, A 8, B 12, which probably, I think we could calculate that. I think 2 to the 4th is, what is this? 2 times 2 is 4. Let's see, wait, hold on a second. I can do this. 2 times 2 is 4, times 2 is 8, times 2 is 16. So on the answer key for the SAT, it'll be something like 16 A 8, B 12 would be the correct answer for that. Okay, so just watch out for that. That's an easy mistake to make with the parenthesis rules. Okay, next, let's try to clear this out. See if we can squeeze one more rule in here. And then let's do this. Okay, so here, let's do rule number 4. This would be the negative rule. If you have a negative exponent, it really just means you need to flip it. Let me explain. So here. Oh, sorry, my pen got stuck there for a moment. Supposing I have this. Supposing I have x to the negative 2 power. All that means, when you see a negative, it just means the base that it's attached to, the exponent, the number, is on the wrong side. So for example, always whenever you see something with a negative, just drop up the division bar and put a 1 there, right? Because hopefully we'd all agree, x is the same thing as x over 1, right? But I like doing this because it allows you to kind of see the two locations where the variable can be. So if we have a number on the top and it has a negative exponent, it belongs on the other side. We have to flip it. So what this would be, the answer for this would be 1 over x squared. Once you've flipped it, the exponent becomes positive. Okay, we're pushing past 5 minutes, but let me just do another example here. Supposing I had something like this. Supposing I had 1 over x to the negative 2. Well, same deal. Even though this time it's on the bottom side of that division bar, we have a negative, which signals it's in the wrong space. It needs to be in the other region. So, it belongs up there, so this would be x squared over 1, or just x squared is the correct answer. And likewise, you can have multiple terms with negatives. So supposing I had something like this. Supposing I had a to the negative 3 over b to the negative 2. Well, both of these, because of the negatives, it's signaling they're in the wrong space. A needs to go to the bottom, and b needs to go to the top. So it would be written like this. b2, a3. Okay? And that's it for negative exponents.